Okay, so this shows you the country music percentage airtime by city and the corresponding suicide rates. Whoa. And there's a lot of data. The really cool thing they did was these guys came in and they can try to control for the other things that might be going on in places where they play country music more often. Maybe the divorce rate's higher. Maybe poverty rate's higher. I love this just southern thing because the gun rate, how many people own guns, and then they finally have the country music playing. And just to show you a couple things, this is a probability of less than 0.05, less than 5%. Would you say that that's statistically significant or not? That's meaning they would see these results in a random situation less than 5% of the time.
Yes.
So that's statistically significant. So that's actually from chapter 6 and 7 and 8. That's we're gonna be calculating those little percentages for ourselves. So then we can report them out to people and say, okay, make up your own mind. Is this significant or not? So I think less than 5% is pretty significant. That's what the original report saw. These guys redid it and they got percentage greater than 0.05. In fact, a lot greater than 0.05. So they said it wasn't significant. There is no correlation between country music playing and people committing suicide, right? And there's all kinds of jokes popping in your head about themes of country music and such. Possibly, I don't know where you guys are going with this in your head. But I just want to show you, and this kind of stuff is a little bit beyond this class. We're not going to quite get this far, but if you're going into psychology or something, you'll be doing a table like this to analyze some data. Because psychologists love to analyze data. They like to try to find connections between this and this, right? What age were you potty trained, and then did you go on and set fires or something? Kind of correlation. That study has been done. Okay, so that's one thing I wanted to show you. And that I wanted to show you the last time. I just forgot about it. No. Oh, this is coming up later. Let me show you this. That's actually from the data that you guys, so it's up to 47, so I'm a little bit happier. 47 of you guys have done that survey. Let me see if I can move this around.
That's what I was asking.
Oh, yeah, that's right. It doesn't like to.
I can do anything.
That's that. That's exciting. Yeah. It should be that. Good. Okay. All right. Can you, in the back there, can you do the one that says whiteboard? All right. Can you guys see that?
Yeah.
Can you guys see that over there? So I asked you on the survey to pick a random number. And in the early going, I was a little disappointed, and it doesn't have to come out a certain way. But is there any number you think, well, you already see it. Which number happened the most?
7.
Now, so is this a very easy graph to read?
Yes.
Yes. Do you think it's a hard graph to make?
No.
This is called a dot plot. This is part of what section 2.4 is all about. So in section 2.4, you're going to have to create your own dot plot. How do you think I made this thing?
Just look at the data.
Yeah, the data goes from 1 to 10, so I had to make sure the scale was consistent. And then I just put a dot every time I saw a 1. That's amazing. All right, so section 2.4 is not difficult. They are very quick ways to give a visual representation of your data. You guys with me?
Yeah.
Histograms. Would you say they're a quick way?
No.
No. 2.4 is a quick way, which means it's not going to be always accurate or anything, but it's a very quick way to get a rough sketch. Would you say this is normal bell curve?
Yeah.
Well, let's see. What's it do? It goes up and then down again, then up and then down again. So I wouldn't say it's bell curve shape, right?
You can't get a bell curve out of something that's ordinal. Can you?
Yes. This is not continuous, but we can still get, what would it look like if it was bell curve? Low, higher, 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 highest, lower, 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 lower. Right? So that would be a bell curve. I can still get a bell curve out of this, even though there's nothing in
Would it have
between,
any
right?
significance to the bell curve?
It might. Would you expect to get a bell curve necessarily out of just pick a random number? Should it be somehow bell curve? That would mean that the middle would occur the most. Which number did occur the most? 7. And that actually is true. It's true. It always occurs the most. Because when I say pick a random number, people say, well, not even. Everybody's going to say an even number. Some weird number like 7. There you go. Some prime, weird. And if I say 1 through 20, and I've done this one before too, the number that's most picked is 17, with 7 being a close second. You can almost put money on this happening with any group of people that hasn't heard this before and knows to kind of skew the data. You can almost put money on 7 or 17.
1 through 4 is 3. They usually do 1 through 4 first, so they pick 3.
Yeah.
And then 1 through 10, so they won't pick 3 again, then they're going to pick 7.
It's true, exactly. So I could have, and see, here's 3 is the next highest here. And the one that doesn't really make any sense to me necessarily is 6 was also tied with 3. They're the same. But, you know, any random, so like anything could possibly happen. But what I expect is 7 to be the highest or nearly the highest for any group of people. Is that interesting at all?
Yeah.
I mean, it's kind of cool. It kind of gives us insight into how our brain works. And it also tells you that we are automatically skewed in our belief about random means, what random means. We're excluding numbers, so we're already not being random. You say, well, not even though a lot of people pick 6. Very often it's not an even number because we think something weird. 7, yeah, that's weird, right? That's what we pick. So.
Is it bad if we actually used a random way to...
No, I love it. And in fact, that would help explain why I got more of certain things. If we truly did random, like we had a 10-sided die, and you rolled it, what should this kind of come out to be? The bigger the sample is, this should come out even. As long as my die is fair, right? So any discrepancy, any deviation from it being even is kind of an insight into how our brains work. Because we're forcing our own idea of random onto this problem, and it's cool to see how it comes out. And this one came out the way that I wasn't necessarily hoping, but this goes along with what normally happens. So, what I want you guys to do real quick, now that you guys all said you could do this, I want you to do this. Not with the same data, of course. But with this data here. Can you make a dot plot out of that?
Should we start the lowest number up there?
Yeah, it's got to be like a regular number line scale.
Should we go from 1 through 10 or should we go from 4 to 9?
You always do the scale based on your data. So it's got to include the highest and include the lowest, but you want it to be consistent scale, right? So I would go 4, 5, 6, 7, 8, 9. You can put 3 and 10 on there if you want to.
We turning this in?
No, this is just for you guys. If you want to, you can put in your calculator and sort it. But a dot plot is pretty quick. You just put a dot every time you see a number. So do you really need this in order? No, unless it was a really huge set of data. I'm going to want it in order.
You tell the side of the bell curve.
Oh, yeah?
Stuff.
I feel bad for the 4-hour night. I could never do that. Man. My whole life I've needed massive amounts of sleep. I'm not one of those that can operate on 2 hours of sleep. Yeah, let's go. So. Why do you think, real quick, that somebody, and this is not true, I didn't make this data up. Why do you think somebody might think I made this data up? Why does it not? Because this is random. This is truly random. What up here strikes you as not being representative of something that's random? You guys see anything about the data that seems to strike you as that can't be random, or
There's not a lot of weird numbers.
possibly? But I would expect people to sleep, 20 hours of the day or something. So this kind of makes sense that it's between 4 and 9. Here, this is what people look at. They say, it can't be 4 8s in a row randomly, 7s in a row. In fact, the 8s go around the corner. What the hell? That can't be random. But that's actually, in truly random data, you have more often runs of something. So if you flip a coin, you will get 5 tails in a row every now and again. You will get 7 heads in a row. But if you just ask somebody to make a list of what would you get if you tossed a coin, they're going to flip it a lot more often than it happens in real life. And again, that's our misunderstanding of probability in that case. All right, so somebody who's a brave soul who wants to let me put that up on the overhead. Anybody have one that they feel pretty good about? Yes?
Yeah, you put one up. I can't count, by the way.
Oh, these things happen. That's right. Depending on the time of day, I can't count either. All right. So let me see here. Well, I was really zoomed in.
Then with the 7.
All right, so what do you think about this data? What's the first thing that strikes you about this data? Maybe about something I asked you about the other data I put up.
I think there's
Bell curve.
5 nines instead of 3.
Oh, 5. Okay, that's fine. So little differences. There are 5 9s. So he gave us the disclaimer that he can't count. That's all right. But I think everybody, did you have basically the same shape? And that shape is important in statistics. The shape here is a normal curve. Because most people should sleep around here, because biologically that's what, on average, most people need, right? This is probably necessity, and this is just
Luxury.
some lucky people. It's true. But that's what I expect to see from this kind of data. I didn't fudge this data. I did not make this data up. This is the data you provided me. I didn't even, to tell you honestly, I didn't even graph this damn thing. I was just kind of hoping it would come out close to a normal curve because I would expect it to. And there it is. You can see the normal curve there. That kicks so much ass for me. Just to tell you, because I was like, holy shit, I have no idea how this is going to look.
Is it usually 7? That's most.
Yeah, 7's normally close to the average. Let me see. Oh. So moving to the next type of thing we're going to look at. Let me just let you guys, some of you guys, of course, are a little ahead of the game, but that's all right. You already know what this means. So don't say anything if you already know what this is and what it means. Try to see what this might represent. Of course, I provide a key up there, so that would probably help. Obviously, if I was you, I'd say, well, it means haircut prices. Right, but what would this point here mean? That's somebody who spent how much on the last haircut? 65. I love it. So this is your stem. My stems. This is your stem, and this is your leaves. It's called a stem and leaf. What the book calls a stem plot, but I'm going to call it a stem and leaf plot. So it's a way to quickly sort the data if it's not sorted, to tell you honestly. And kind of like subcategorize it and then sort within those subcategories. So it's a quick way to sort data. But also, if you look this way, it makes like a histogram. Very quick, rough and dirty histogram. And would it be normal? Thankfully, it's weighted in the direction I would expect it to be. Bless you. Most of us are in college, so we don't have a lot of money. So for haircuts, just make it shorter than it is. And then I'll go eat some ramen noodles and get to class, right? Trust me, I've been there. So I expect it to be weighted that direction. But a few people obviously either have, much longer hair or, whatever. That's why I'm so happy I was born a man, to be honest. I could never spend that much time on my hair. All right, but again, let me ask you the same questions. This was a relatively easy graph to read. Do you think it was difficult to create this graph?
No.
No, it wasn't difficult to create this graph. So could you do that same? Could you create a graph like this, given a list of data? Yes, you hopefully you could. So let's try a list of data out. Oh, here's a good example. Let's see here.
Page is this on?
This is page 68, section 2.4. So if you have your book, you might want to take a look there. So see the data I'm talking about in the middle of the page there? All right, upper part of the page. Okay, cool. Freeze on. My fingers are still.
I know, like, oh.
Now on this data, would it make any sense for my stem to be 1 for 100, 2 for 200? Why would that make